information technology and solid residue management. A case of study using freeware and social networks. The authors would like to thank the support received in their home institutions. Regional University Center of Espírito Santo do Pinhal, Federal University of São Carlos, Municipal Faculty Professor Franco Montoro. Abstract. Separation, collection, processing and disposal of waste considered recyclable are currently one of the greatest challenges of human beings in their quest for sustainability. With consumption levels in ever higher levels, the reutilization of recyclable waste, which would likely target the garbage, becomes an obligation of society as a whole. The project iCARE, Instrumentation for the Assisted Collection of Recyclable Waste, is based on an experiment that aims to provide computational tools that could contribute to the issue of the reuse of solid recyclable waste. Specifically, the iCARE software aims to contribute to the integration between owners and collectors of recyclable materials, establishing a communication channel where ordinary people or companies may announce the availability of recyclables to collectors. Introduction and motivation. Every day, tons of materials that could be recycled and returned to the consume chain are thrown away as trash. The result of this negligence is and this. In this way, the planning and implementation of programs dedicated to the selective collection of recyclable materials can contribute to the solution of various environmental, social and economic problems. Under the economic point of view, the selective collection effectively promotes the solution of many problems, considering that discarded materials can go back to the cycle of consumption, thus reducing the use of natural resources in the manufacture of new products. Under the environmental point of view, the reuse and recycling of materials would probably promote direct impact on the preservation of natural resources, conserving raw materials, water and energy in production processes and, consequently, a decrease in the amount of trash sent to landfills. In the social aspect, the selective collection has positive impact on socioeconomic conditions of recyclable material collectors, who are the first actors in the selective collection chain. The steps in the process of collection and disposal of recyclable waste can be viewed in a simplified way, as follows. 1. Separation. This is the step where each citizen must separate, from non-reusable waste, those materials which can be recycled. This is a step based on education and awareness of people about the need to reuse materials that can go back to the cycle of consumption. 2. Collection and disposal. This step has a logistic profile, since it involves several costs for those that are collecting reusable materials. Collect which materials? Which is the minimum amount viable for collecting? How to collect and give destination? 3. Processing. As well as the collection and disposal stages, this one can also be seen as a business, where a particular company may have focused on the reuse of recyclable waste and its subsequent commercialization. This is the step of the recycle chain that is more distant from ordinary people, considering that here the main actor is a businessman. In this context, this work presents an experiment carried out in a city in São Paulo state, Brazil. The work that is being carried out includes the creation of computational tools which intend to support the process of selective collection of recyclable materials. A local context to the issue of waste recycling. According to the City Hall of Mogigetu, a small town with around 120,000 inhabitants in Brazil, the share of production of household garbage by the population is approximately 105 tons each day. 99% of the garbage is collected. 32% are recyclable materials. 52% are organic and 16% are considered waste. According to the Brazilian National Association of Collectors of Recyclable Materials, pickers can collect an average of 600 kilograms of materials per day. In this scenario, a matter that can be displayed is how to integrate consumers, who generate such amount of potentially recyclable material that is currently going to junk, and collectors, who while may give the appropriate disposal waste can also improve their source of income. It is in this scope that iCARE presents itself as a technological arm that aims to generate computational tools that will contribute to the solution of socioeconomic and environmental issues, among them the problem of proper collection and disposal of recyclable materials. Introducing iCARE. What's iCARE now? In its current stage, iCARE is a software that intends to integrate consumers, those who generate garbage, and collectors, those who are the first actors in the recycle chain. iCARE expects to take advantage of the popularity of modern digital tools, computers, tablets and smartphones, now accessible even to the low-income population. iCARE also intends to present a democratic and decentralized structure. iCARE is based on a bulletin board, which offers an interface for sending messages, through which an user can offer the donation of materials that can be recycled. An interface for receiving messages, through which an user can check the materials available for collection and contact the respective donors to this schedule. A route generator interface, through which a collector can establish a collection of routes through certain criteria. The decentralized structure of iCARE means that any city can implement its own database server and bulletin board, serving data for the local population. In this structure, local consumers, those who generate garbage, may leave a list of recyclable materials in the bulletin board of the city. In turn, local collectors, those who pick up the recyclable materials, may check the bulletin board of the city and verify which materials are offered for recycling. Software structure. iCARE is based on a database that holds messages sent by consumers to collectors. Database server runs in Apache Derby, an open-source RDBMS that is based on Java technology and SQL. The client bulletin board was written in Java. It works only in computers yet. Collectors and consumers have to download the client to use it. They must have an internet connection. Using iCARE. Before using the bulletin board, consumers and collectors must be connected to a database. This database may be the one available in the city of the users. However, users may connect to other databases in different cities. This is why we consider iCARE a democratic and decentralized structure. It must be provided the IP address and the port of the server that consumers or collectors want to connect. After a successful connection, users will see the bulletin board interface, and will be able to send and receive messages. The interface for sending messages. In this interface, a consumer may leave a list of recyclable materials for donation. He must first click on the New button to start the generation of a new message. After that, the date field will be automatically filled, with the date, time and IP of the consumer computer. At next, the user must provide information about the recyclable materials he wants to dispose. The field's material, quantity and measure unit must be filled. In sequence, he just have to click on the Add button. The material offered will be displayed in the whiteboard below. Consumers may add more materials after this, or click on the Send button to publish his message. The interface for receiving messages. To receive the complete list of messages, a collector just have to click on the Receive button. The complete list of materials offered for donation will be displayed in the whiteboard called Bulletin Board. If the collector doesn't want the complete list, he may use the filter field, writing a list of words that synthesize the kind of materials he wants, for instance, glass, paper, aluminum. Next, he must click on the Receive button. Clicking on the message on the bulletin board will present the content of this message, what kind of materials someone has to donate, the amount of this material, a way to contact the donor, and the date when the message was published. The collector may click on the Save button to save this message as PDF file, for future reference. The route tracing module. Through this module, a collector may trace the minimal route among the places where he will collect recyclable materials. With this feature, he may plan the best way to pick up materials, saving time and fuel for instance. This module was written in HTML and JavaScript, working outside the bulletin board, in a web browser. Its use is very simple. In the box at the right side of the browser, just insert an address to be located and, then, click on the Add to the Route button. Insert all the addresses of the route that you want to trace. Next, just click on the Trace Route button at the bottom of the interface to trace the route. So, what's next? Concluding remarks and future steps. As presented, the iCARE project aims to contribute with the separation, collection and proper disposal of solid wastes, as a way to minimize the socioeconomic and environmental problems arising from the inappropriate treatment of waste. But iCARE is still in its early stage, so there is a lot to do to improve it. It also seeks to involve the largest possible number of people interested in the collection and disposal of recyclable waste. People currently using iCARE complain that the bulletin board must be downloaded to use it. They are asking for a new version that could run directly in a web browser. Users also request that this software should also run on smartphones and tablets, not only in computers. The interface must be improved significantly. Local schools are requesting that iCARE must also include educative actions in its scope. The use of this software has allowed the operation of a structure for the collection and disposal of waste, which has been organized by the Association of Collectors of Mogigeku, in Brazil, ensuring the entry of materials to the collective work of everybody involved. The proposal of a programmed logistics makes selective collection activity itself less impressive due to the reduction of fuel consumption and emission of greenhouse gases in the collecting of materials with the planning of routes. Thank you.